Hey Martin, it's Rob. I just you had asked for a follow up, so I sketched a few things out. One is sort of a cross section, looking through the wall, looking through the ceiling, of what I found on site, as far as if this is the dividing wall, how much we have above the drywall. We actually have an inch and a quarter currently just in front of the cabinets. I have an inch and a quarter from the top of the drywall to the underside of the pipe. I know that once we get to the wall, we have to go another 5 feet, but with a quarter inch per foot of fall, if I need to go 5 feet, I need that inch and a quarter exactly before I'm physically touching the drywall. And given the fact that I measured that point out in front of the cabinets, I figured the cabinets are 2 feet deep plus crown, and I cut a little bit further out. I'm 28, maybe 30 something inches out from the wall, give or take. So if I go 5 feet from there, I'm still about 2.5, maybe 3, give or take, feet from hitting that wall, which I think is still out too far from being on top of the cabinets. So what I was thinking about is, well, how can we increase that height so we get this pipe up higher and jog it across a longer distance, so that by the time I hit this wall, I'm still higher up. And I just got off the phone with the engineer. He's going to switch the quad 11 7/8 LVL beam that's going to run across the kitchen into an 8-inch steel beam that's packed with wood, so that we can minimize that height of the beam and keep more height underneath these joists. These joists are 2x10s. These ones are 2x12s, further packed with strapping. And when I actually went on site, I measured exactly that the strapping was 3 1/8, leaving 11.5 inches for the actual joists. These joists were 9.5, I think, or 9 3/4, give or take. But then they're well above all the height that we're going to continue the ceiling across at, because we're going to go flush with the ceiling as it continues. So we have this whole void to run this pipe across, provided we're high enough to stay above the existing drywall line as we jog across. And then at the very last minute, even if I drop below the ceiling inside 2 feet, I get in and underneath the cabinet, and then we can sheet it down on an angle below the ceiling if we have to. But I need to get at least within 2 feet of that wall, like you had pointed out, so that we can get in above the cabinets and not have to worry about the ceiling any longer. So with that all said, I sketched this thing out to scale. I'm just going to pull back a bit. I actually drew it exactly to scale. So this line up here is the subfloor, the underside of the subfloor. This is the joist here to this point. Currently, the existing horizontal stack drain at the end that I measured it, or not at the end where the toilet is, but at the hole out in front of the cabinets, I have an inch and a quarter below the pipe down to the top of the drywall. So that's reflected here. So it starts at 1 1/4 inches above the drywall, and that's the width of the pipe. As I get across, this is very exaggerated because I drew it over a piece of paper. It's not actually that slope, but as I cut across over a number of feet, all I need to do is make sure that I dip underneath the bottom of this joist, which is the joists of the office / dining room. As long as I'm underneath those, because those are the ones that run this way, and the bottoms I can't notch into, so I have to get underneath that line. That's the critical line. So what I'm thinking is, if we go from the point that I cut well out into the ceiling, which is 7 feet from the cabinets, I found the elbow where it goes up to the toilet. If we can either cheat that a little bit higher and just squeeze a little bit more height closer to the subfloor as cast iron, or conversely, if you're okay with it, if you don't so much mind about the noise, or even if we do it and we put some Roxol Safe and Sound around it to minimize noise, what we can do is probably switch it to an ABS pipe, which would actually, the elbows of an ABS pipe are narrower. They can sit higher than the cast iron, which is a much longer curve. So if we start back here, up higher, and continue the same slope, by the time we get to the point out in front of the cabinets that was 1 1/4 inches, maybe if we started up higher, I could be somewhere closer to 1 3/4 inches, maybe 2 inches, again depending on how much we can raise that in by. But if we can get that to be anything more than 1.25 inches, even 1.5 inches, 1.75 inches, if I can have even 2 extra 1/4 inches, that means 2 extra feet that I can run across the ceiling before I'm on top of this drywall. So the reason I drew this line is to show that I have 5 feet from this current existing point until I'm literally on top of the drywall with the fall that we need. So any bit of inches or 1/4 inches at a time that I can start higher at the 7 foot from the cabinet mark where the toilet loops up to the ceiling, or up to the floor above, I should say, the more this goes up, and then I can slip it across and keep it higher here, keep it on a gentle curve. As long as I slip underneath those joists, I'm good, and then I can get past there, stay up higher, and then all of a sudden that point where it hits the drywall is now, over here or over here, and then it gets me within 2 feet of the cabinet, and then boom, I drop into the top of the below the ceiling on top of the cabinet. So the way we're going to achieve that is by putting in, this is a 9 3/4 joist. We're going to be putting in an 8-inch steel beam, which is going to have, I'll just draw it out for you. It basically looks like a giant capital I. That's the steel beam. So that's what's called the web, and these are the flanges. So the steel beam comes like that, and then we pack out with a 2x, and we pack out another 2x, and then we put a bolt through that so that it locks the 2 pieces of wood into the steel web, and they're resting on this bottom flange. So it's the wood is also carrying the weight just the same way as it would be if something was resting right on the steel. So once we do that, then we could even take it further and lengthen the bolt and go through a 2x12 that hangs down lower, bolt through that so that this piece of 2x12 becomes almost the same. As soon as you bolt them all together, they act as one structural load, or one structural member, I should say, so that as soon as this is all bolted together, these pieces of wood, the one 2x12 and then the 2 smaller 2x8s that are bolted into the steel web, are essentially all one member, so that hanging the joists that run across and putting a joist hanger on with nails and stuff is basically the same thing as hanging it right on the steel itself. We've just used wood to make it easier to fasten to. So essentially what we're going to have is this steel I-beam with wood packed out to the front of the flange. Then we're going to hang a vertical 2x12 on the flat, and then run our joists up to that with joist hangers and bolt through those 3 pieces of wood through the steel, and now everything's locked together. And then the joists on this side will continue to run this way as they already do, but they'll be up high enough that this pipe that's cutting through here stays, sorry, I'm just trying to hold the paper as I'm shooting the video. This pipe that comes across here continues on but stays underneath these joists, but stays above the drywall, which is actually 3 inches below the bottom of this joist. So I actually have more room to play with. So as long as I can get underneath that beam and stay as high as possible, I can get further with this pipe before dropping down into the wall below. So that's the goal here, and that's why we're going to get an 8-inch steel beam here. The engineer's working on it right now. He's going to put together the specs, figure out exactly what type of 8-inch beam we need, and then also because that's happening, where that 8-inch beam lands, we have to have a beam across the 6-foot opening from the hallway into the kitchen. That also needs to be a steel beam, and then the steel needs to sit on 2 steel columns, transferring the load down to the masonry wall below. So he's going to put all that together, work out the specs of what we need, and soon enough we'll have that information and we can move forward on that front. But I'll get that information to Alana as soon as the engineer confirms that. In the meantime, I'm glad I worked it out. We do have just enough room to sneak it by, if provided we can get that pipe to start a little higher, which I'm going to review with the plumber. If he can get that pipe to start a bit higher, we may be able to buy that extra 1/4 inch or 1/2 inch to run that extra foot or 2 feet and get us closer to that end goal wall, or at least within 2 feet of it, so that we can drop it into the cabinet. Hope that helps. Thanks so much.